What if your AI assistant could answer questions using your own documents accurately every single time? Hey everyone, welcome back to SkillSnap. I'm Vaishnavi, and today's video we are going deep on one of the most powerful and widely used techniques in AI right now, RAG, which stands for Retrieval Augmented Generation. By the end of this video, you will understand exactly what RAG is, why it exists, and how each component works under the hood, and how companies are using it in real-time products today. We have also got side-by-side comparison showing the difference between a pure LLM and a RAG-powered answer, and trust me, the difference is dramatic. So, if you're learning AI, building AI applications, or just want to understand how tools like ChatGPT with document upload actually work, this video is for you. Let's get into it. Before we dive in, here's a quick roadmap of what we'll cover today. We'll start with the RAG, actually what RAG actually is and what problems it's going to solve, and then I'll walk you through the complete architecture, the full end-to-end pipeline. We'll look at each core component one by one: document ingestion, vector embeddings, vector database, and then I'll show you a real-world example and also show you the difference between RAG and pure LLM, and finish with the most popular frameworks you can use to build RAG apps yourself, including the actual code snippets. This is a full deep dive, so I recommend you watch it with the timestamps in the description if you want to jump to a specific section. Alright, let's start from the beginning. So, to understand RAG, you need to first understand what the problem it solves. LLMs like GPT-4 or Claude are trained on massive amounts of text data, but the training happens at a fixed point in time. After training, the model's knowledge is frozen. So if you ask a pure LLM what happened about something in the past or last month, or if you go and ask about your company's internal policies or a product update from the last week, it simply doesn't know. It either says like, I don't know, or even worse, it hallucinates. It makes up something. So this is called as hallucination. And there are three core limitations of pure LLMs. So firstly, as we discussed, it's like the knowledge cutoff. They do not know what happened what happened after their training, because their knowledge is frozen after training. And hallucinations. They generate plausible sounding but absolutely wrong answers. And there's no private data. They cannot access your internal documents or databases or any other information. So what does RAG do here? RAG solves all of these three problems. So if you see the full name of RAG, it's a Retrieval Augmented Generation. So before the LLM generates any answer, yeah. So before the before LLM generates any answer, RAG retrieves relevant and up-to-date information from a knowledge base, and then it injects that into a prompt. So now the LLM is now working with the real sourced context and not just its training memory. Like think of it like a way. Imagine you are taking an open book exam, and a pure LLM is like taking the exam with no book or just your memory. And RAG system is like taking that same exam but being allowed to look at up things in the textbook first. And the answers are far more accurate and verifiable. So we'll head to the architecture section to understand more about RAG. So this is how the full architecture of RAG looks like. You see there are two pipelines. First pipeline connecting from the documents to the vector DB, and the second pipeline connecting from the user query to the final output. So let's look at the full architecture. First phase is also known as the indexing phase. Whatever is there here, this phase is known as the indexing phase, and the below phase is known as query phase. So what happens in the indexing phase is Um, like firstly, you have to start with some raw, let me erase this as well. So what happens here is, firstly, in the document phase, you will upload different kinds of documents. That documents can be PDF, that documents can be in any of the format like text documents, docs, or HTML. So what are these documents? These are nothing but the documents from which you want information, or the documents, whatever the data you want the system to know about. Next stage will be, these documents will be sent into a chunker. So what happens is, when you have, for example, a full line RAG full architecture pipeline. So this is a full sentence. This chunker will split this sentence into different level of blocks or chunks. So basically they are known as chunks or tokens. So you will run these documents through a chunker, and it will split them into smaller pieces, like typically of 300 to 1000 tokens each, and with a small overlap. Why do you need overlap? For example, if I just chunk it like this, and let's say you want to again get, when you get the output, that output would not be in an order, and you can get the output as a RAG architecture full pipeline or RAG pipeline architecture full, something like that, which is completely inappropriate. So if you include some sort of chunking like this, for example, this is one word, this is the next word. So this chunk overlap which is there, which will help you to connect between the two of the words. Now, once the process of chunking is done, it is sent to an embedder. So what happens in this embedder? It is a text embedding model. It will convert. So now we are dealing with words. Now this embedder will convert this into some kind of numbers. Let's say some vectors like 0.1, 7.8, and so on. So whatever these words could be represented with, those numbers it get converted to. So the embedder's job is to convert these chunks into a vector. It would contain a list of numbers that actually capture the semantic meaning of the sentence or the chunks. Now these vectors which are generated are now sent into the vector DB. So what does this vector DB do? It will store all of those vectors which are generated, and it will index them so that we can search fastly. So it was used for searching tasks. Now, when this is done, this is the indexing phase which we have completed for the documents we have. Now, next, what is here? Here we have the user query. Who is the user? You or I is the user, and here we send any of the question in any of the natural language. Let's say I am asking the system, what is artificial intelligence? So that is my question, and I am sending that question through the query in natural language. Now, can I compare this natural language with something of the vectors? No, you cannot do that. You cannot compare text with numbers, right? So what we will do is, later, the next step would be conversion of this natural language into the similar kind of vectors, or a vector representation of user query. So in the next step, when you go to the next step, this embedding query is used. So we are using the same embedding model in both of the phases, in the indexing phase as well as the queried phase. So the user query is embedded. Now the user query is again converted into a list of vectors, carrying the semantic meaning of the user query. Now, next what happens is, next we have the retriever task. So here is a main task where you will integrate the indexing phase and the embedding phase. So from the indexing phase, what are we going to get? We are going to get this list of vectors which are representing the relevant documents which we passed. Now from the embedding query, we have this user query vector. Now both of them are sent to the retriever. In retriever, both of them are sent. A semantic or a similarity search is performed. So based on the similarity of user query and the vector stored, it will retrieve the top case similarity search. So the we will consider, let's say after doing similarity search, I got 10 similar documents related to my query. I will take top k. We can consider k as anything. So for instance, I'm taking 3 documents or 3 document vectors as relevant, and this 3 document vectors along with my user query, both of them are sent to my context prompt. So this is, I mean, both of them are sent to the LLM. So this is the context, whatever the document which is retrieved, whatever the documents we sent as relevant, those plus my user query will go as prompt to the LLM. Now once this is done, here my LLM will perform the task of searching through the similar documents with respect to my user query and will give me my output, which is nothing but my required answer. This is how this is how RAG works. This is how RAG is elegant to that of an LLM, and its job is to read the retrieved context and synthesize a clear answer like a very smart summarizer in reasoning abilities. So if we go to the next slide, you will understand faster. So if you see the RAG flow, which we discussed earlier, I am the user, I am sending a query. Now my query cannot be sent as it is. So I am going to vectorize my query using an embedding model, and that query is sent to search through the vector database. Where it is going to search? Vector database. Why it is going to search in vector database? In my indexing phase, I am uploading the documents. The documents are chunked, and those vectors, the chunked documents are vectorized and they are stored in my vector database. So this vectorized user query is going inside, and with my vectorized documents are going to the LLM. So these are being augmented with the relevant context and query, and this is going to my LLM. Now my LLM will only search through the relevant context and the query and will give me or generate me an answer. Now that response is sent back again to user, that is me. So it is basically indexing, vectorize and store, and then augment and then generate. This is how LLMs work. I hope you guys got a clear picture of how how the LLMs and the RAG framework work together. So the core components of RAG is, so firstly, we should talk about the document ingestion and chunking process. So as I've talked earlier in the ingestion pipeline, firstly, we need to load the documents, clean them, split it into chunks, and then tag the metadata and then store the chunks. So basically what happens, for example, if you have to upload your company data or some internal policy where you want to get information about, what you will do, you will upload the document. First you will load the document and then upload the document, and after uploading document you will remove some outliers or some unstructured text, or remove noise from, and only take the exact structured text. Now, as we discussed earlier, we have to split the text into chunks. So, with 10 to 20% overlap in order to make sure they come in the same order. Next, we need to tag the metadata, and then whatever the data is there, whatever we have done till now, the chunking, all of that we have to store the chunks because we have to send them again to the embedding model. Now, if you see in this slide, you can see the document chunking. So for example, this is the document and I have a RAG tutorial document which has different sentences. Now, if I split, see, this is my chunk 1, chunk 2, 3 and 4 and it has, you know, overlapping windows. I will tell you. For example, if you see in the chunk 1, it is RAG stands for Retrieval Augmented Generation. It is a technique that you can just underline this one, a technique that. Now, if you see my chunk 2, it will start with this line, a technique that enhances LLMs by providing relevant external context. Now, in my chunk 3, it will again start with external context before generation. So this whatever is highlighted, that is the chunk overlap, and these chunks, they are the document which is split. Next is vector embeddings. So if you have heard about embeddings earlier, this is a quite easy topic, and if I have to talk about this, it is nothing but converting a text into a list of numbers, basically vectors, and these vectors have to capture the semantic meaning of the text. Like it has to have similar meanings that produce similar vector. For example, if you see the machine learning and the deep learning here, for machine learning, you have the vector as 0.23, 0, minus 0.85 and 0.44. Now for deep learning, if you see 0.21, minus 0.82 and 0.46. So these two words, machine learning and deep learning, they are very much similar. They are used in similar context. So if you see the vectors which are, to which they are converted to, they are very much similar. You do not see much difference here. Next, if you see the Python loops, so this is similar, but not much similar to that of the machine learning and deep learning. So you have the vectors far away from the machine learning and the deep learning vectors. For the machine learning, you have it as like 0.23 and 0.21. Now, if you see for the Python loops, it's like 0.71, 0.33 and minus 0.02. So embedding model does nothing but converting the text into a list of vectors. Now, if you see in the Python, if you see the Python cluster, AIML cluster, database cluster, and web dev cluster, here in the vector embedding space, so here, if you see in this AIML cluster, you have deep learning, LLMs, and all of that. Now, if you go to the database cluster, you will have SQL, vector DB. So, whatever similar things are there, they will have similar vector representations and similar meanings clustered together in a higher dimensional space. So when you want to search the vector database, you will not do a keyword matching. You will measure the geometrical distance between, like you can understand it as like a cosine similarity. If you have to measure the distance between this point and this point, see, you will have to find out the cosine similarity here. Now, if you want to find out the RAG pipeline and RAG explained in deep learning, how similar they are, you will find out the cosine similarity between these 2 points, and they are quite similar here. So, the cosine similarity, it's like nothing but the angle between two vectors, and angle 0 means they are in identical direction, and if the angle is deviating, it means they are unrelated. So there are few popular AI, it's like the popular embedding models. One is the OpenAI ADA 002. It is, and the other is Google Gecko, and SBERT and Coher V3. And the number of dimensions, it determines like how much information the vector can encode, and more the dimensions and it means like higher quality, but it's slower search and more storage. Next comes the vector DB. So now we have embedded the vectors there. I mean, we have converted the text into vectors. Now where are we going to store those vectors? Those vectors cannot be stored in a normal SQL or Postgres database. We have to store them in a database called as vector database, which is specifically designed to store and search vector embeddings at a scale, and it's like very much fast. Like for example, um, uh, if you have to search in your MySQL and Postgres SQL, you search by value or you search by a range. You will give the exact value, like I want to find the employees who have salary less than 50,000. That is how you find in a Postgres SQL or a MySQL database. When it comes to vector database, it doesn't happen that way. For you will if you want to know how the vector search works, firstly we will wait until the query arrives. For example, I am giving my user query, how do I reset my password? Now after giving this query has to be embedded, since I have to search it with the vectors in my vector database. Now I am embedding the query with a list of values, and now I am going to perform a search where I will retrieve the top k or the top n results, and with that results I am going to calculate the cosine similarity with respect to my query and those results, and then again retrieve the top 3 relevant resources. So for example, we have many other, the most popular vector databases are Pinecone, Chroma, FAISS. So this FAISS is a Facebook one, and Chroma, all of these are open source, and VV8, Quadrant, and PG Vector as well. They, they are most useful for, I mean, in such operations, and Chroma and fires are particularly recommended if you want to go for a open source and a local machine one. Pinecone or Quadrant for production. Now if let's see a real world RAG in action with a real world example. Like I want to walk you through exactly how a customer support bot built on RAG would answer a question. So the company is SkillSnap, and that's our own channel. And a user asks, how do I reset my account password? So as we have learned, first, the user asks the question. That question is converted into a query embedding that goes for the vector search and the retrieves context. Now that context is along with the user query is sent to the prompt, and that prompt is sent to LLM, which will generate accurate answer for me. Now coming to the last topic, um, that is the RAG versus pure LLM. So if you see, for example, SkillSnap likely offers a 30-day refund, and most likely on the SaaS products, allows cancellation, and all of this is there. If I ask the LLM to respond to this question, it will give me a hallucinated policy. Like, okay, it will not actually get the SkillSnap data. If I want to ask LLM a question about skill snap, about how it works, it will give me answer, but it hallucinates and it will not give me the actual data. And in comparative to RAG will give me a perfect answer. Like it's giving me a 7-day full refund on annual loans, no refund after 7 days, and email support is something skillsnap at support.io within 7 days. Now, if you see something for the RAG, it says SaaS products, it just says refund, and you see the difference. it the RAG is giving something which is sourced from the actual documents, and it is as specific and as accurate. The RAG does not hallucinate, but LLMs, they do hallucinate. So that's how RAG is different from a pure LLM. Now, in the process of entire thing, we have seen a place where both the context and the user query get merged or kind of get combined. So that place is nothing but the prompt. So the prompt is very specific thing, and the prompt has to be well structured in RAG. So if you see the system prompt, so for example, you are a helpful customer support, answer only if it's provided context, else say I don't know, do not make up any information. Now you have the retrieve context and you will ask user question. It is generating answer for us. So for example, if you give, this is your instruction to the LLM, and it tells the model how to behave, what role is it, and critically how to answer from the provided context and not make up things. And here for the retrieved context, these are the actual retrieved chunks from your vector database, and it would include like top 5 or top 10 most relevant chunks, usually within the source labels, so LLM can cite them. And this is the actual question that user has clearly labeled. So if you see here, do not make up information, this is critical. It turns out a hallucinating model to a grounded one. So this is how, like, RAG prompts are built. And lastly, coming to the RAG frameworks and code, um, the great news is that you do not have to build anything from scratch. There are like fantastic frameworks that can handle RAG pipelines for you. And let me show you 4 of them. First is the LangChain. It's like the most popular ecosystem, and it has like built-in loaders for almost like 100 sources, text splitters. It has embedding integration, vector store integrations, pre-built chains, and everything. Like with like if you can write like 5 to 10 lines of code in LangChain, you would be building a rapid prototyping projects that would need that could contain broad integrations. You can just write like 1 line of code and then retrieve, you're calling the retriever here. So LangChain is like the most popular one. Next is the LlamaIndex, and it was formerly called as the GPT index. Now this is also an optimized like for data ingestion and indexing part of RAG, and it has like the most sophisticated chunking strategies and better handling of complex document structures like tables, PDFs, and engine abstraction. So this could be recommended like for production applications, like if it has to handle like very much complex documents accurately, then we use the LlamaIndex. Next, we also have the Haystack, like it's by DeepSet, and it's like an enterprise focused framework with modular pipeline architecture. It has built-in evaluation tools, and it is also used for production systems. It can be best used for enterprise use cases and compliance heavy environments and pipeline observability. And LangGraph, it is newer and it will take a different approach. It will help you to build it's like you build RAG from as a stateful graph where each node in the step, where each node is a step in the pipeline. Like it unlocks that agentic RAG systems that you can decide that, that RAG only itself can decide whether to retrieve or how many times it has to retrieve, and it can self-correct its answers. So it's mostly used for the advanced multi-step RAG agentic system workflows. And in our next video, I'll build a RAG app from scratch using LangChain and ChromaDB, and we'll give you a full code walkthrough, and make sure you subscribe so you do not miss it. So, all right, let's bring it together. You have just learned every major component of augmented generation system. And here's a quick overview. The document ingestion is loading, cleaning, and chunking your data into retrievable pieces. Vector embeddings, converting text into numbers that represent semantic meaning. And vector databases, storing those embeddings and enabling lightning fast similarity search. Retrieval for finding the top k most relevant chunks, and LLM generation, combining the retrieved context with the question to produce grounded and accurate answers. So these 5 components are the foundation of almost every production AI application that deals with the private or the current data, from customer support bots to document QA tools to represent and to enterprise knowledge bases. So if this video helped you understand RAG, please give it a like, and it's really helps the channel grow, and tell me to make more dives, more deep dives like this. Subscribe and hit the notification bell so you do not miss the next video where we build a full RAG application from scratch using LangChain and ChromaDB. Real code, real project, and step by step. Drop a comment below if you have any questions, and if you want me to cover a specific part of RAG in more depth, or just tell me what the AI topics you want to see next. I'll see you in the next one. Keep learning, keep building, and I'll see you there. Thank you.